All right, let's get started. Good morning, everyone. This is Saber Feki, the scientist team lead here at the Couch Supercomputing Core Lab. And we have today a training about our leadership supercomputer, Shaheen, here in my background. And that training is meant to be more than introductory, but it will actually include a lot of best practices and tips and tricks to optimize the use of your our supercomputing facility. So first of all, let me start with what is KSL. KAUST Supercomputing Core Lab provides state-of-the-art supercomputing facilities, training and services to most of the constituents of KAUST research, from student, faculty, postdoc, researcher, and so on and so forth. But also we intend to serve the supercomputing needs of the Kingdom of Saudi Arabia. And you will see that we have not only reached out to universities, but also government and academic and industry. And our goal with that is to become a reference, world-class reference in supercomputing. So the way we provide our services is first we have 3 layers of services: the infrastructure, which is mainly the supercomputing facility. Then we provide expertise to help users to use that infrastructure the most efficiently possible, to maintain it and upgrade it over time, and so on and so forth. But then on top of that comes a set of expertise ranging from computing cycles, having time on the machine, to consultancy from experts from the teams that I will share with you in a minute, who have specialization in different scientific areas, and HPC as well. And then we provide education and training. So today is one of these sessions where we educate our users and the community at large about what is HPC and how we use it, specifically for KAUST infrastructure. Comes next is a community building events where we work and collaborate with other constituents of the kingdom and build a community around HPC and AI. And last but not least, we provide value-added services. One example is when we provide customized packages or tools or libraries for users to enhance the performance or the productivity of their research. So with that, as I mentioned, all of these services are the culmination of the effort of a very brilliant scientific team, which I have the honor to lead. And those are 6 PhDs in not only in HPC in computer science, but they have a skill set ranging across multiple disciplines. So this multidisciplinary team covers computational fluid dynamics, for example, material sciences and computational chemistry, bioinformatics, applied mathematics, and data science as well. So this is the scientific team that is the closest to users, to you guys, and interact with you day in, day out to solve problems, install software stack, and provide training and consultancy. Of course, there is another team who maintains the system. That's the system administration team, and takes care of your accounting and of your core hours and so on. But this is your first line help typically. So moving on, let's start the first part of our agendas today on our training on Shaheen infrastructure. And the first part is about the architecture. So we'll learn briefly about the system architecture, and then we will understand how that's being used in terms of software and end user perspective. So very, very high level abstraction of what is a supercomputer. So it starts with a set of large number of computational nodes. We call these are servers with what we have today is x86 traditional CPUs, but the high end of that, which have a large amount of memory and computational power that is optimized for scientific computing and data analytics. Next to that, also all these nodes are interconnected with a fabric of interconnect, and that interconnect also is linking them to a high performance storage or more. And we will see the examples of Shaheen, how that's working. So unlike a traditional laptop where you have the compute, the CPU, and the disk next to it, here you have the storage network connected and mounted via the high-speed network, mainly to get the performance of very large installation of storage. Then what you guys interact with the supercomputer is the login node. So the login node is when you land once you get into the system, and then you write scripts to interact with the scheduler that span jobs across the files, across the computing nodes, and so on and so forth in a most efficient manner. And of course, for people who interact and collaborate externally, you have a data mover that helps you bring in data or expose data to the outside world. So how that's in Shaheen? So for Shaheen, our computational power is the Intel Haswell CPU processor with 32 cores, with 128 gig of memory. So on aggregate, we have nearly 200,000 cores with 6,000 plus CPU nodes. And that's consuming nearly 3.1 megawatts of power. So it's outstanding numbers, and that's the heat dissipation of those basically needs to be water cooled to maintain it in operational temperature. In terms of speed, these nodes were able to achieve, theoretically, they achieve a 7.2 petaflops, but using the state-of-the-art benchmark Leanpack, we achieve a sustained performance of 5.5 petaflops. That put us at the top 7 worldwide in 2015. We are today at 89, and we are refreshing our system, obviously, to get back onto the game. But how that's achieved is mainly because these nodes are not loosely connected, but more tightly connected with a very fast interconnect called the Aries interconnect, which is proprietary network. And we're gonna cover that into a little bit more details in the next slides. In terms of storages, we have multiple tiers of storages, the fastest being the data warp, which is very close to the compute with a smaller capacity, 1.5 petabytes, but very high speed, 1.5 terabytes per second. Then comes disk-based storages. So we have the Scratch file system with a 17 petabyte, very fast with 500 gigabytes per second. And for capacity now, it's more of a performance issue. We added 37 petabytes this year in order to provide the capacity for the users in an appliance, lustre appliance, to add capacity. This storage, the last one for project, is actually backed up with double copies using our tape library. So let's dig in a little bit deeper, and in the next 2 or 3 minutes, into the system. So the architecture is built using a blade is the main component, it's the first component, and each blade is a 4 CPU nodes. Each CPU nodes is double socket Intel CPUs, and each one of those is connected through PCI Express to a Cray Aries interconnect. So that Cray Aries chip basically has multiple links that allows this blade to connect to the whole system in a multi-level all-to-all communication, which is called the Dragonfly topology. So for the first layer, and you can see here the top of a blade, you have in the backplane of a chassis of 16 blades, an all-to-all communication. And the next level comes in with the second rank of all-to-all communication between 2 cabinets. So here, each cabinet is a 3 chassis, 6 chassis together in 2 cabinets group. We call that a group. And then we have a second layer of all-to-all communication between all these chassis. Then here you see in the picture, so these are coupled communication because they are short distances. When we go to the longer distances, you see here these green cables on the top going upward. So these are the fiber optics that connects the third layer of all-to-all communication and connecting all the groups within a supercomputer. So Shaheen has 36 cabinets, that's 18 groups, and they have 8 fibers between each 2 groups in all-to-all fashion. That's nearly 20 kilometers of fibers. Not only that, so the richness of this network enable what we call adaptive routing. So that's independent from the users, you don't see it, but it is providing the performance and scalability across multiple nodes. Now we come to the storage. We have started Shaheen 2 with the Scratch parallel file system. That is a Sonnection 2000 cluster file system with 12 cabinets. That's nearly 6,004 terabytes drives. So look at that and you will see a few years later how the technology evolved in our latest upgrade. So we use InfiniBand to connect that to Shaheen, which is a fast, low latency interconnect. And then it has 144 OSTs or storage targets. And you will see that that's one of the areas where you can use to optimize your I/O. So /Scratch now is the Sonnection file system. /Project is now the new Lustre 2 E1000 parallel file system. So this is the new 37 petabytes. And that's actually how it's built. It's only 5 cabinets now to get double the space, the capacity of what we have before, mainly because we use 16 terabytes drive now. Okay, so it's half of the number roughly, but you have 4 times the capacity. So that's doubling the performance in half the space. Again, this is connected through InfiniBand fabric, but it's connected through HDR to IBEX and FDR to Shaheen 2. So this storage specifically connects both systems that KSL operates, Shaheen and IBEX, and that allows actually multiple workflows to happen. So if you have one of these cases, please reach out to us and we can help you out. Last but not least, on top of Shaheen, we have a pre-post processing system, which seems to be useful for quite a number of use cases, where we actually have 20 compute nodes with more recent CPUs, with local disk as well. And those basically provide a system that is capable for pre and post processing your data. So it mounts both Project InfiniBand or through InfiniBand, the Shaheen Lustre file systems, Project and Scratch. Then your data is there, and then you can do all the visualization, post processing, preparing meshes for CFD codes, and so on and so forth. Not only normal compute nodes, but we also have some high memory. So in case 128 gig or 192 gig is not enough, we have up to 768 gig of memory in a couple of nodes. So if you have some of these demands, please let us know and we can get you access to this. So with that comes the basic infrastructure description of Shaheen ecosystem in terms of hardware. Then we move on to how to get access to that. So people, how to get accounts and so on and how to use it. And then we move forward to explaining all the details of how to take advantage of this facility and use these core hours and your accounts there to run your scientific workflows. I give the floor now to my team to walk you through the next steps. Thank you. And